Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1343, number of subarrays of size k and average greater than or equal to threshold. This is a medium difficulty Leetcode problem, and in the problem description we're told that we're given an array of integers called ARR, array, and two integers k and threshold, and we want to return the number of subarrays of size k and average greater than or equal to threshold. So we're given a threshold, we're given k, and we're told we want to find the number of subarrays of size k, and the average should be greater than or equal to the threshold. So let's look at an example. In this example, we have k being equal to 3, threshold is equal to 4, and the output is 2 because there are 3 subarrays which have the averages 4, 5, and 6, which are greater than the threshold, greater than or equal to the threshold of 4. And all other subarrays of size 3 have averages less than 4. Okay, so let's get something out of the way first, and we want to find out basically, this looks like a sliding window problem, but we want to know when do we want to slide our window and when do we want to add or when do we want to increment our result counter by 1. We need to have some sort of condition, right? And so we want to say, we know first of all that the average is greater than or equal to threshold. So if the average is greater than or equal to the threshold, one of those conditions is met. We know that the average is obviously going to be equal to the sum divided by k. So it's going to be equal to the sum divided by k. And what we can do is we can rearrange these two formulas and basically, or equations, sorry, and come up with a solution of sum being, or actually, sum should be greater than or equal to the threshold times by k. So sum should be greater than or equal to the threshold times by k. So the sum of all of the numbers in our window should be greater than or equal to the threshold times by k, not times by 3. And if that is the case, we will increment our result counter. So let's get straight into the code. We now know the condition for this problem for our sliding window. Now let's actually get into implementing a solution. So we want to start off with the window sum. So the window sum initially is just going to be equal to the sum of the first k elements in our list, and we want to just get the target. So we're going to get the target is going to be equal to the threshold times by k. So that's the target, and we want to say count is initially going to be equal to 0, but except it's not, because remember we have an initial window here. So we want to say it's going to be equal to 1 if the window sum is greater than or equal to the target. Else it's going to be equal to 0, sorry. Okay, so those are our preliminary conditions and variables set, and now we can just do our sliding window. So we can say for I in range of, let's pass in k, and then length of array, window plus equals array I, window minus equals array I minus k. So those are our sliding window conditions. And then we want to check if the window sum is greater than or equal to the target. Well, then all we can do is simply increment our count by 1. And then once we've finished from our for loop, we can just return the count, which will contain our result. And submitting our code shows us that we pass all 69 test cases for this problem. Fantastic. So what does the time complexity look for this problem? Well, it's just a single linear pass. So the time complexity for this problem is going to be big O of n. And the space complexity, well, that's going to be done in constant time. So because we're only referencing a couple of variables, so that's going to be a big O of 1 space complexity. So I hope this video made sense, guys. Remember, the key really is figuring out how to rearrange these equations and find out that the key is that the sum should if the sum is greater than or equal to the threshold times by the k value that is passed into the function, then we count that as a subarray which satisfies the condition of this problem. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.